Hi guys, in this video I'll show you how to create an advanced Tableau chart called the Ghentt chart. We started in the in-person class talking about the Ghentt chart, its importance, the fields where we use it, and the definition or the meaning of these bars over here, which in fact represents the sizable distance between a certain minimum and max. So in our hospital data set, we want to see each patient visit to the ER department in 2018. So when we're talking about the ER department in 2018, this means that we need to apply a filter on the department and a filter also on the year, and understand how long each visit lasted. So we have an admission time as well as a discharge time, and with that we can find out the length of the period of stay in the hospital, whether any patients return to the hospital. This is very important. So we want to see the time horizon, the timeline of the different visits of patients to the hospital and the length of each visit. So each patient might have one or more of these bars. So over here we have a different representation. Over here we have the software event log, but in our example we're going to talk about we use the hospital database. We would like to see multiple bars here if any of the patients were admitted more than once. So how do we do that? The first thing we do, of course, this should be the output. This is what the output should look like. We should have the patient ID or the patient name, and I'm going to talk a little bit about this in a bit. And over here on the axis should be a time, of course, the date of admission. And then these little bars over here will be basically the sum of days in the hospital, which is the period from admission to discharge, and this is the sum of days. We're going to make a calculated field to compute that. And then also we're going to do the wait a minute, why do I have the patient name here in the filter? It has all patients, right? Yeah. Okay, so let's see how things unfold. Okay, so let's begin. How do we do that? First of all, let's talk about the axes and the headers. We want to know for each patient the time of stay in a Ghentt representation. So we can use either the patient name or the patient ID, but that is not really precise statement. In principle, you need to use the patient, because we want to show the patient, the same patient, remember, the same patient here in one line, yeah, in one line. So it's best that we use the patient ID, but because in this data set the patient name is not we don't have Nora Cherkassi twice. Like here in Japan, I believe the names are very much similar to one another. Like we can find many Yo Yamamoto, we can find many Mika Yamamoto, for example, and so forth. So in this case, and this is why they use the birth date, a combination of a birth date and your name. So over here in this case, the best option for us is to use the patient ID, so that we can make sure that Mika Yamamoto is not repeated twice, and we're not sure if this is the same Mika Yamamoto or not, right? But in this case, in this data set that we got, guys, we don't have Aaron Day twice, or we don't have Alex Harrell twice. We just have one Alex Harrell in the data set. It just happened. All right, so let's put the patient name. But if you want to put the patient ID also over here to just make sure that every patient is a unique patient, regardless of the name repetition or duplication, sorry, then you can do that as well. Because I just feel like this is too much space. It's consuming too much space. I'm just going to take it out for now. All right. So now we have the patients. We want to see their visits over time. So we need the time. So let's take the date of admission and not the date of discharge. Why? Because the date of admission is before the date of discharge. So basically the timeline here is more inclusive. So here's the date of admission, but this date of admission is, as you can see, in a blue pill. So we need to put it in an exact date. This is one step or one very important note when you are creating a Ghentt chart with Tableau. So you need to make sure that the date of admission is in fact an exact, set to an exact date. So what are these little bullets mean? This means that at this day, Aaron here has been admitted into the hospital. So this is the start date of being admitted into the hospital. I wanted to create a bar, and for us to create a bar, a mark here, create a mark of a bar of a beginning and an end date, a start and end date. First of all, I need to understand that I need, what data do I need? I need the discharge date minus the admission date. And this would be, let's create here a calculated field and call it period of stay, for example. And this period of stay should be defined as the date of discharge minus the date of admission. This is what you think it should look like, but in fact, if you do that, the calculation is invalid. It's actually valid, but if you're doing this, let's do this versus doing it differently. What is differently? These are not numbers, all right? Date of admission and date of discharge is not a number, it's a date. And for us to, let's check here. For us to subtract dates, we need to use the appropriate function, which is the date difference. Date difference, so try it, please try it, take your time and try it. Try this measure versus a measure that takes the date difference. This date difference function returns the difference between two dates where start date is subtracted from the end date. It doesn't matter, there's a number of days. The difference is expressed in units of date part. Which unit? We have many units of date part. If determined by the start day configured for the data source. So basically, we need to use this date difference function. So let's use the date diff function, and then in there, this is how you write it, the date part. What is the date part here? The units, the output. So the output here should be day, and then the start date is in fact the date of admission, so the order is important, and then the end date is here. And let's get rid of whatever comes after that. So this calculation is valid, we apply it, and here's the period of stay. Let's take the period of stay and throw it in there. No, we don't do that. But if we did it, it's also smart. Actually, I didn't know that it's smart. This is smart. In fact, I just wanted to make sure that you understand the period of stay is on the size, yeah? So even if you throw it in there, as you can see, smart enough to detect it as this. Now we haven't started with the filtering. We just want to see the ER department. So I'm just going to filter using the ER department, and also we would like to see the date being 2018. So this is years, and in years I just want 2018. So now this is the data in hand. Would like to order. This is why we have probably here the patient. Would like to order the patients in terms of the minimum here. So the minimum of date admission. So let's sort here based on ascending but based on a field, and this field is period of stay, but not sum. I want based on the starting date. Yeah, so I'm going to start with the minimum because it's based on the starting date. Well, it didn't, wait a minute. So sort field ascending, not period of stay. I'm sorry. Where is the date? Admission date, the date of admission, the axes. I'm sorry. Yeah, that does make a difference. And the aggregation is not count. Again, the aggregation is minimum. Yeah, now we're talking. Now we're talking. So you see, guys, I'm sorry. I just by mistake it's the minimum on the axes, right? So the minimum of the date of admission. Yeah. So the minimum of date of admission, you don't have to really memorize things. It just doesn't make sense that you are sorting. I made a mistake. I don't know how. I made a mistake sorting on the period of stay. Why would I sort on the period of stay? It's sorting on the axis. So the axis here is that date of admission, and look at this. Voila! This is what we're looking for. You see this Joshua, for example, has been into the hospital 3 times, and there's improvement. I mean, the first time he stayed in the hospital, he stayed longer than the second time and the third time. There's not any improvement here, almost same, and so on. So you can see how each patient, the number of stays of each patient, and you see why we're doing the minimum. So this is what you're supposed to get doing or performing this kind of exercise. Now, will you get the Ghentt chart here? Let's check. This is not a Ghentt chart. This is heat map. This is text tables. This is simple maps. This is maps also. This is pie chart. This is bar, 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 bar. This is tree maps. This is something else. This is something else. This is line, line, line. This is area, area, area. This is line and area dual combination. And this is boxed and whisker. So basically we don't have the Ghentt chart here, seems to be. Even if we start, let's all over, putting here the exact date, and here's the, I'm recreating, yeah, here's the patient name, okay, and then we still don't have anything on the show me, yeah, and then have we the period of stay. There is no need for it to be here. You see, it detects it automatically. So the Ghentt chart is not really available. Right? Where are we? Okay, so this is it for the Ghentt chart. I'm gonna move on to the next. Yeah. So next step, we're going to talk about plotting here the number of patients per department, but also based on their risk profile. So this will be in the next video. So I'll see you in the next video.